A cubic has equation y is equal to x cubed plus ax squared plus bx plus c, and has turning points at 1, 2, and 3d for some d. What is the value of d? So I think I'm just going to take all the information that's given and translate them into mathematical expressions. A lot of them will involve taking derivatives and so on, and then just see if I can solve for some of the unknowns. So oh, well, no, I guess the value of c will kind of matter here. Okay, I will want a derivative, so that's going to be 3x squared plus 2ax plus b. So the first thing I know is that when I substitute x equals 1 in here, I get 0. Same when I substitute x equals 3 in here, I get 0, because the turning points are at 1, 2, and 3d. So the derivative is 0 at these two values of x. So 3 plus 2a plus b is equal to 0, and also 27 plus 6a plus b is equal to 0. So this allows us to solve for a. 24 plus 4a is equal to 0, so a is equal to -6. And then if I use the first equation here, 3 minus 12 plus b is equal to 0. So b is 12 minus 3. b is equal to 9. And I should be able to solve for the value of c in the original polynomial now. So I have x cubed minus 6x squared plus 9x plus c. And I'm given one of the points on this cubic. It's 1, 2. So when x is 1, this is equal to 2. 1 minus 6 plus 9 plus c is equal to 2. So c is equal to 2 minus 1 plus 6 minus 9. C is equal to 8 minus 10. C is equal to -2. Okay. And now I should be able to figure out what the value of d is. And that's just going to be taking this polynomial and evaluating it when x is equal to 3. Of course, now I can substitute. I know c is equal to -2. So when x is 3, I have 27 minus 6 times 9 plus 27 minus 2. So that's 54 minus 2 is equal to -2. And that's option B. I'm confident in this as long as I didn't make any arithmetic mistakes. I mean, the idea here is we have 4 unknown pieces of information, A, B, C, and D. But we can you can even think of the value of D as not being something unknown, but something that will be directly given to us. If we think of A, B, and C as being the unknowns, then we have 3 pieces of information. We have 2 locations where the derivative is 0, and all the information about 1 point that's on the curve. So you can solve, in principle, for A, B, and C, and then just directly compute the value of D. So like the method, I'm sure is sound. As long as I didn't make any arithmetic mistakes, I'm confident that this is the answer. If I find a mistake though, I'll let you know. Thanks for watching.